Today's notes start with a review problem. So I want somebody to pause the video. I want everybody in the class to try this problem. Once most, if not all of you have it, play the video and it'll show the solution, how to get it. So it asks us to solve by substitution. When we solve by substituting, we are going to replace something with what it's equal to. So in this case, the equation that says A equals, the second equation here, I know A is equal to 2B plus 4. So what I can do is I can take what A is equal to, in this case 2B plus 4, and I can substitute it in for the A. I can replace A with 2B plus 4. So I have 3A minus 4B equals 10. 3A, but instead of A, I'm putting this in, minus 4B equals 10. But instead of the A, I'm putting in 2B plus 4. Now we have an equation that we hopefully can solve. Our first step in solving this would be to distribute this 3. So I've got 3 times 2b, that's 6b. 3 times 4 is positive 12. And I'm just copying this part here down, minus 4b equals 10. I have some like terms. This 6b and this minus 4b are both on the same side of my equation. So I'm just going to combine them up. 6b minus 4b is 2b plus 12 equals 10. And now I'm down to a two-step equation that we should be able to solve. I'm going to subtract 12 from both sides. Giving me 2b equals 10 minus 12, which is negative 2. 2 times b equals negative 2. I can solve for b by dividing both sides by 2. And I get b equals negative 1. Once we get one of our variables, in this case b, we need to get the other one. We get the other one by plugging negative 1 back into one of the original equations. It does not matter which one, although the one that is solved for one of the variables is generally the easier one. So if I plug negative 1 in right there for b, it would say a equals 2 times negative 1 plus 4. I replaced my b with what b is equal to. I put negative 1 in for my b. Order of operations, we multiply and then add. So I'm going to do 2 times negative 1. Negative 2 plus 4 gives me a equals 2. That is my solution. A equals 2, b equals negative 1. That solution, if I plug it in for a and b into both equations, it's going to make both equations true. So that was solving by substitution. We've been working on that for a couple class periods now. We're going to move on to the third and final way to solve systems of equations, and that is a method called elimination. Solving a system of equations by eliminating. So example 1 asks us to solve the system of equations, and we are given 5x minus 2y equals 5 and 3x plus 2y equals 11. 5x minus 2y equals 5, 3x plus 2y equals 11. Notice this time, neither one of my equations say x equals or y equals. Also, last class we took a look at a problem where I could solve for one of my variables and then substitute, which works well if one of the variables has a coefficient, or one of the equations has a variable with a coefficient of 1. The problem is if I try to substitute on this, if I solve for any of my variables, like here, if I solve for this y, I'm going to have to subtract 3x and then divide by 2. Well, 11 divided by 2 doesn't come out even, and negative 3x divided by 2 doesn't come out even. And then when we substitute, you're going to have fractions in there. So it could be done. There's just a better method to use. So elimination works great if my x's and y's are all on the same side. So the word eliminate, it means to get rid of. We are going to eliminate, we're going to get rid of one of the variables, and we're going to do it by adding the equations together. So what we want, our goal is to add the equations together and eliminate, get rid of a variable. Add equations, get rid of a variable. Either x or y. This problem that is given is set up nicely for us because if I add the equations as they're written, notice right here I have minus 2y, and right here I have plus 2y. So if I add the equations together, negative 2y plus 2y, that cancels out, which works out great. So we can go ahead and add the equations together right away. Negative 2y plus 2y, those cancel. 5x plus 3x is 8x. Bring down my equal sign, and 5 plus 11 is 16. I get 8x equals 16, which overall is a pretty easy equation to solve. 8 times x equals 16, so I undo that multiplication by dividing both sides by 8. And I get x equals 2. Just like with substitution, I not only need the x, I need the y as well. We're going to go back to either equation. Again, it doesn't matter which one. Generally, I'd pick the one with smaller numbers, although they're all kind of about the same on this one, so it doesn't really matter. I'm going to do the bottom equation here. Plug in 2 for your x and solve for y. So if I plug in 2 for x, I'm plugging it into the bottom equation. I get 3 times 2 plus 2y equals 11. And if you wanted to plug it into the top one, 5 times 2 minus 2y equals 5, that works just as well. We are solving for y then. Here I've got 3 times 2, which is 6. Subtract 6 from both sides. I get 2y equals 5. And divide both sides by 2. Y equals 5 over 2. You can write it as 5 over 2. If you really want to write it as 2.5, you can. 2.5 is fine. I get x is 2, y is 5/2. Let's take a look at example 2. Example 2, again, we were asked to solve the system of equations. We have 3a minus 2b equals 21, and negative 6a plus 7b equals negative 51. The problem with this one is I cannot start by just adding the equations together. The last one, it worked out great because right here I had minus 2y plus 2y, and they canceled. If I look at my a's, I've got 3a minus 6a. Those don't cancel. And here I have negative 2b plus 7b. Those also don't cancel. So I don't want to add my equations together yet because I would not be eliminating either one of the variables, either the a's or the b's. So what we want to do is we want to make this system so that it looks like the one in example 1 where I can add the equations together and cancel. And we can do that by multiplying one of the equations by anything we want, as long as we multiply the whole equation, both sides of my equation, by that number. So looking at the a's here, I've got 3a, and then I've got minus 6a. So they'll cancel if this one, instead of being a 3a, if it was a 6a, if this was positive 6a and then minus 6a, they would cancel. So I need to multiply this equation by 2. And I'm multiplying it by 2 so that I get 6a here. 3 times 2 is going to give me 6. Now I'm going to rewrite my equations. I'm going to multiply this whole equation by 2. 3a times 2 gives me 6a. Negative 2b times 2 is negative 4b. And don't forget to multiply 21 times 2, giving us 42. So I multiplied this whole top equation by 2. The bottom equation, I didn't change at all. It stays exactly the same. Negative 6a plus 7b equals negative 51. And now this system of equations looks very similar to the last one we did, because I've got positive 6a, negative 6a, plus 6a minus 6a, those cancel. Negative 4b and plus 7b, those combine to give me 3b. 42 minus 51, this would be a calculator problem. 42 minus 51 gives me negative 9. Three times b equals negative 9. Divide both sides by 3, giving me b equals negative 3. Now we're going to take negative 3 and we're going to plug it back into either one of the equations. Again, it doesn't matter which one we do. You can use these equations over here if you want, although the original equations are going to have smaller numbers. This first equation, all of the numbers, the 3a is smaller than 6a, 2b is smaller than 7b, 21 is smaller than 51. So I'm going to plug it into the top equation, although technically it doesn't matter which one you use. So I'm plugging negative 3 in for b into this top equation. So I've got 3 times a minus 2 times b, but instead of b, I'm putting in negative 3 equals 21. I'm not worrying about this times 2. I use that to get this guy over here. And we're going to solve for a. Negative 2 times negative 3 is positive 6. Negative times negative is positive. I've got my 3a. I've got my equals 21. Subtract 6 from both sides. 3a equals 21 minus 6, which is 15. Divide both sides by 3, and I get a equals 5. A equals 5, b equals negative 3. Example 3, similar problem. Asks us to solve the system. 7c plus 3d equals negative 5. 4c plus 6d equals negative 50. Again, we don't want to add the equations together yet. If I add the equations together now, my c's don't cancel, my d's don't cancel. So I want you to think for a minute about which equation you could multiply and by what. This is 7 and 4. Those are going to be tough to make the same. 3 and 6, those are going to be a little easier to make the same. If I multiply 3 times 2, that gives me 6. The problem is if I multiply it by 2, this is going to say plus 6d and plus 6d. 6 plus 6 does not cancel out. 6 plus 6 gives me 12d's. So when we add the equations together, remember I always want one to be positive and one to be negative. Here I've got one positive 2, one negative 2. Those will cancel. So instead of multiplying this top equation by 2, let's multiply it by -2. And that should give me minus 6d here. And now when I add my equations together, I should be good to go. So multiply everything by -2. That gives me -14c minus 6d equals -2 times -5. Negative times negative is +10. My bottom equation did not change. 4c plus 6d equals -50. Now I can add the equations together. Minus 6d plus 6d, those are gone, those cancel. -14c plus 4c is -10c. 10 minus 50 gives me -40. Divide both sides by -10. Giving me c equals 4. Once I have c equals 4, I go back to either one of the original equations, doesn't matter which one. Plug in 4 for your c and solve for d. I'm going to plug into the top equation. I'm putting 4 in for my c. 7 times 4 for c plus 3d equals -5. Seven times 4 is 28. Subtract 28 from both sides. I get 3d equals -5 minus 28, which is -33. And divide both sides by 3. d equals -11. c equals 4, d equals -11.